Alright? So, the next topic we're going to discuss is paano ba gagamitin ang virtual work method sa pagkuha ng deflection natin sa truss po natin. Okay, so as you can see, meron na tayong derived formula na pwedeng gamitin, okay, sa pagkuha ng deflection sa truss natin. As you can see, we have three formula here. Okay, so i-discuss natin yung bawat formula. Okay, yung unang formula, okay, this formula is used for us to determine the deflection due to loadings. Okay? So, siyempre alam natin, pagka yung structure natin may load, siyempre magde-deflect yan. Okay, so ito yung ating formula. Okay, due to the loadings. Right? So, dito sa unang formula po natin, so we have here 1 times delta. Okay, yung ating deflection. So, 1 dito, as you all know, okay, ito yung unit load natin. Okay, so sa truss natin, ang niloload lang po natin dito is 1 unit concentrated load. Okay, is equal to the summation, okay, of FV. So, what is FV? FV here is the member force. Okay, so truss kasi ito, no? So, member force due to the virtual load. So, yan yung FV. And then, yung F natin dito is yung member force. Okay, member ng truss natin, yung force for each member due to the external load. Okay, yung load mismo ng truss natin times L. L is the length of the member all over AE, which yung A natin dyan is the area or cross-sectional area of the member, and E here is the modulus of elasticity. Okay? So, maliwanag ba? So, ulitin ko lang, yung FV is the member force due to virtual load. Okay? Pwede natin sabihin na virtual member force. And then we have F here. That is yung actual member force natin. And yung L natin is the length of the member. And then yung A natin is the cross-sectional area. Okay, of the member. Okay, so summation siya. Ibig sabihin, i-add po natin lahat nung FV times F times L all over AE. Okay, yun na yung pagkuha ng deflection due to external loadings. Okay, ito yung unang formula natin. Yung pangalawang formula, okay, yung pagkakaiba lang dito is yung nawala yung FL over AE. Napalitan po siya ng alpha times delta T times L. Okay, yung FV is same. Yan yung member force due to virtual loadings. Okay, yung FV. So, yung A natin dito, yung alpha, okay, is the coefficient of thermal expansion. Okay, ito yung isang property ng material natin. Okay? So, ito yung alam naman natin na kapag nagbago yung temperature, okay, sobrang init, sobrang lamig, di ba, nagkakaroon ng deformation kaya yung ating mga member. Okay? So, ito yung pagkuha ng deflection natin. Yung formula na to is pagkuha ng deflection due to, this is number 2 is due to thermal temperature changes. Yung una is due to external loadings. Okay? So, kailangan mo lang i-memorize itong formula na to. Ano? So, yung pangalawa, nasa pangalawa na tayo, is due to temperature changes. Pagka nagpalit yung or nagbago, okay, yung temperature natin, may posibilidad na magkaroon ng deformation. Okay? Kasi nga, pwedeng mag-expand o pwedeng mag-shrink yung mga material natin. So, yung alpha dito is yung property ng material natin, yung thermal expansion property niya. Okay? So, this must be given sa figure, sa ano natin, sa problem natin. Okay? And then, delta T or the change in temperature. Ayan. Change in temperature. And then L here is the length of the member. Okay? So, yun yung number 2. So, ulitin lang natin. 1 times delta is equal to the summation of FV times alpha times delta T times L. Okay? So, yung coefficient of thermal expansion natin is ang unit nito is per degree Celsius o depende o per degree Fahrenheit. Depende na lang sa ibibigay na given dun sa ating problem. Okay? So, kung papasilin natin, yung temperature natin is in degree Celsius halimbawa. So, magka-cancel lang yung ano natin. Ang matitira dito is FV, that is in kilonewton kung ano tayo, nasa kilonewton. And then yung length natin is in meter. Okay? So, ang magiging sagot natin dito, yung delta natin dito, yung 1 unit load natin dito is naka kilonewton. If naka ano tayo, no? SI unit, ano? Kilonewton. Yung delta is equal to, yung FB natin is in kilonewton. Itong dalawang to, alpha times change in temperature is maka-cancel yung degree Celsius natin or any unit in terms of temperature. So, kung mapapansin mo, maka-cancel yung kilonewton. Okay, for both sides. So, yung delta natin dito is in meter or yung mismong unit nung length natin. Okay? So, next, number 3. So, ano yung formula na to? Number 3. Ito yung due to tuloy lang natin. Hindi nakita, no? Number 3, due to fabrication errors. So, yung due to fabrication errors. Okay, so, meron kasi time, ano? Merong mga in real life, no? Na sa plano, or hindi nasusunod yung mismong dimension ng plano natin. Okay, so merong yung mga napuputol na mga member na mas maikli dun sa supposed to be na length or mas mahaba dun sa supposed to be length nung ating truss mismo. Okay, dahil doon, siyempre ipipilit nilang habulin ano yung correct dimension. So magkakaroon siya ng stress na agad. Okay? Dun sa ating truss dahil pipilit nila halimbawa kulang no kulang yung length dapat yan yung total length ganyan lang nakuha so ito yung connection so kailangan idugtong ano so dahil doon magkakaroon tayo ng deformation okay yung formula na gamitin natin is this one okay so dito ang bago lang is ito okay yung ating sigma Okay, so the sigma here denotes to the uh, yung actual or yung given na uh, length. Okay? Or yung shortage or excess length. Yan. A shortage or excess length of member. Okay? Pag shortage yan, negative. Pag excess, plus, positive. Okay? So, given naman yan, no, sa problem natin. Sasabihin naman niya na yung member AB is meron siyang uh, shortage in length of 10 mm. So, that's negative 10 mm. Ganun. Okay? Or yung uh, member BC is sobra naman ng 15 mm. So, plus 15 mm. So, yun yung ilalagay natin dito sa sigma sa ating formula. Okay? And then, add mo lang yun per member. Yun yung makukuha na natin. Okay? So, dito, yung magiging value ng delta natin is, o yung unit ng delta natin is depending on dun sa binigay mo na unit dun sa sigma. Okay? Kung ang nilagay mong sigma dito is in mm, so ang lalabas na agad dito is in mm na. Okay? So, let's use yung mga formula natin in actual problems. So, unahin na natin yung number 1, due to external loading. So, ulitin lang natin yung formula. 1 times delta is equal to summation of FV quantity FL or all over AE. Okay? Okay, so example number 1. Okay, so dito, uh, sige, so the problem, okay, determine the horizontal and vertical components of the deflection at joint B of the truss shown in figure by the virtual work method. Okay, ang gagamitin natin is virtual work method. Okay, so hinahanap horizontal and vertical deflection. Saan? Sa point B natin. Okay? So, sa formula, ulitin lang natin. So, one way to memorize the formula is always write formula. Okay, so 1 delta is equal to summation of F V quantity F L over A E. So, given naman yung A natin. So, EA is constant. Okay, so yung area is 1,200 millimeter square. Okay, cross-sectional area. And then yung modulus of elasticity natin is 200 gigapascal. Okay? Yes. So, ang unang gagawin natin is for us to determine F and FV. And also L. Okay? So, unahin na natin yung pagkuha ng actual member force due to the loadings. Okay, so paano kunin? So dito, lahat ng member ay dapat natin kunin. Okay? Pero kung may makita kang zero force na dyan, so automatic, ilagay mo na yan, no? Para mas madali mong kunin lahat ng member force natin. Okay? So dito, may makukuha ka ng agad na member force by just looking, okay, dun sa ating figure. Okay? Ito yung nasa gitna. Kasi sa point B natin, okay, yung point B natin, meron tayong nag-iisa lang na vertical member. Okay? Automatic summation forces along Y direction. Itong member na to will be equal to 84 kilonewton. So, this is tension. So, mahalaga yung sign convention natin. Ha? So, pag tension, positive. Pag compression, negative. Okay? Mahalaga yun. So, next is, nakuha natin isa. So, dito tayo sa point A, magsisimula. Okay, so para makuha yung member AD and AB, kailangan lang natin na kunin yung reaction dito muna. Okay, we assume na meron tayong force dyan and dito. Okay, this is AX and AY. So, sa AX natin, pwede natin kunin yan kasi siya lang naman yung nag-iisang reaction na horizontal. Okay? So, malamang na ang ating AX is 35 kilonewton. Okay? Maliwanag ba? Then, let's solve AY. So, para ma-solve ang AY, summation force a moment at point C is equal to 0 positive clockwise. So, mag-moment tayo sa point C ngayon. Okay, unahin na natin yung mga external loadings. So, we have negative 35 times 4. And then we have negative 84 times 3. Okay? And then 35 is neglected. So, matitira dito is AY. Last, no? Na force natin is AY. So, positive AY multiplied by 4 plus 3, that is 7 meters. That is equal to 0. So, what is AY? Well, paki-solve. So, 56 ang AY natin. Kilonewton. And then, we can now solve for CY. Ang CY natin is 84 minus 56. That is 28 kilonewton. Okay? So, nasolve na natin lahat ng reaction po natin. So, next po na gagawin natin is solve na natin yung member forces natin. So, nahin sa joint A. This is joint A. So, meron tayong external forces. We have the 56 kilonewton and we have the 35 kilonewton for AX. And then, nandito na yung ating member force for AD and member force for AB. Okay? Assume tension always. So, this is AD. This is AB. Okay? So, makukuha natin yung angle dito. Okay, yung angle of AD. So, 4 yun. So, this is 45 degrees. Okay, so, let's solve for AD first. So, summation forces along Y is equal to 0, positive upward. So, we have AD sine 45, okay, plus 56 is equal to 0. So, AD is equal to negative. So, 56 divided by sine 45, yun yung magiging AD natin. So, yung AD natin is 79.1959. So, we can say 79.2. Negative means compression siya. So, kailangan pa rin natin yan, ano? Yung negative dyan. Okay? So, nakuha nyo ba, class? Okay. So, next, AB na tayo. So, summation forces along X is equal to 0. Positive going to the right. Okay. So, we have 35. We have AB. And we have uh, AD, positive AD cosine 45 degrees. That is equal to 0. Okay? So, 35 plus AB plus AD. Okay? Yung AD natin dito, so as you can see, hindi ko pinalitan yung direction mula dun sa assumption natin. So, pwede natin ilagay yung nakuha natin dito, negative 79.2. Okay? Cosine 45 is equal to 0. So, ang AB natin ngayon is equal to, so negative 79.2 cosine 45 minus 35 or plus 35 I should say is negative 21. And transpose natin siya magiging positive 21. So, ang AB natin is positive 21. Okay? Kilonewton. Okay? So, pwede natin ilagay dito. So, this is negative 79.2 and yung AB natin is positive 21. So, sa point B natin, as you can see, dalawa lang sila na horizontal member. So, we can say this is also positive 21. Okay? So, next, sa point C tayo. Yan. Point C. So, meron tayong vertical reaction dito na CY that is equal to 28 kilonewton. And then, we have here the member force. Okay? So, ito yung ating DC or CD. CD. And ito yung ating BC. Okay? Yung BC natin is positive 21. Okay? So, kunin natin yung CD. So, that is summation forces along Y is equal to 0. Positive upward. So, we have here CD. So, meron tayong angle dito. So, as you can see, this is a 3, 4, 5 triangle. So, here, pwede nating sabihin na this is 4 all over 5. Okay? Bakit 4? Kasi dito triangle natin, ang kinukuha natin is yung vertical component. So, that is 4 all over the hypotenuse. 3, 4. The hypotenuse is 5. So, 4 all over 5. Okay? And then, plus 28 kilonewton, that's equal to 0. So, ang CD natin is equal to negative. Okay? So, negative 28 times 5 divided by 4. So, 35. Okay, negative 35 kilonewton ang ating CD. Okay? So, pwede natin ilagay dito, negative 35. Okay? So, kompleto na tayo sa actual member force. So, next na kukunin natin is the virtual member force. So, ganun pa rin, the same structure. So, pwede natin burahin ito. Pwede tayong gumawa ng another. Yes. Sige. Copy na lang natin itong. Gawa na lang tayo ng bago. Ano? So, gawa ko dito sa medyo baba. Okay, dito ko nang burahin ito, no? Muna, bago na tayo gumawa. Burahin ko muna ito mga to. Okay. Ayan. So, gawa tayo dito ng the same structure. Okay, the same structure tayo dyan. So, meron pa rin tayong the same support. Okay, this is a AY, AX, and CY. So, we have here also a point B, point C, point D. Okay? So, next, let's load the virtual loads natin. Okay, so horizontal and vertical components. So, unahin muna natin yung vertical components. So, sa vertical components, ang gagawin lang natin, maglalagay tayo ng vertical unit load. Saan? Sa point B, kung saan tayo naghahanap ng deflection. Okay, 1 kilonewton. Okay, so i-load natin sa point B. Sa horizontal naman, okay, the same. Gagawa ulit tayo ng panibagong structure. Okay, or the same structure. Ang ilolod naman natin is yung horizontal na 1 kilonewton. So, unahin muna natin tong vertical na 1 kilonewton. Okay? So, mag-load tayo dyan. So, magkakaroon tayo ng reaction. Ano? So, dito, alam na natin na this is also positive 1 kilonewton. Okay? So, ganun pa rin, unahin natin na isolve sa point A and then point C. Okay? Para magawa yon, we need to solve AY. So, summation forces, mali. Summation moment at point C is equal to 0, positive clockwise. Okay, hindi ko nakalimutan, AX dito is 0 kasi wala namang ibang horizontal force. Okay, so moment ako sa point C. So we have here negative 1 times 3. So the same dimension, the same length. Okay, so 4 meters to 3 meter. So 1 times 3, negative yan. And then positive AY times 7 is equal to 0. So ang AY natin dito is equal to 3 all over 7. 3 all over 7. Okay? And then yung CY natin ngayon is 1 minus 3 all over 7. That is 4 all over 7. Yes. Okay, next, sa point A tayo. O, joint A. Sa joint A, meron tayong AY dito, 3 all over 7. Meron tayong AB, positive AB. And meron tayong AD. Okay? So, para makuha yung AD, summation forces along Y is equal to 0. Positive upward tayo. We have AD sine 45 plus 3 all over 7 is equal to 0. So, ang AD natin ngayon is negative 3 all over 7 divided by sine 45 degrees. Okay? So, ang lalabas na sagot natin is 3 square root of 2 all over 7. So, pwede natin gawing decimal, 0.61. Okay? Or kung gusto natin medyo accurate na konti, mas accurate, so pwede natin gawing 3 decimal point, 61 point, sorry, 606. Yan. Negative 0.606 yung AD natin. So, ang AB natin is summation forces along X para makuha yung AB. That is AB plus AD cosine 45 degrees is equal to 0. So, ang AD natin dito is negative, yung AD natin is negative 0.606. So, magiging positive siya. Cosine 45. So, ang AB natin is equal to negative. So, magiging positive siya. 0.606 cosine 45. That is 0.429. Okay? 429 ating AB. Okay? So, next, we can now write this here. So, ang wala na lang sa atin is yung CD. So, same, no? At joint C. Bakit negative nilagay ko dito? So, pakibura na lang yung negative dito. Positive dapat yan. Tension na. Okay? So, dito, ito yung CD. Okay? Assume tension. Okay, summation forces along y is equal to 0. Positive upward. So, we have CD 4 all over 5. Okay? Positive yan. Positive 4 all over 7 is equal to 0. So, CD is equal to, so magiging negative siya. No? So, that is negative 4 all over 7 divided by 4 all over 5. So, sagot is negative 5 all over 7. Okay? Maliwanag ba? Yes. Okay, so pwede natin ilagay dito negative 5 all over 7. Okay? So, tapos na. No? Hindi natin murahin ito para malinis yung ating solution. Yun. Okay? So, gamitin na natin yung formula. So, gusto natin kunin kasi vertical unit ito nilagay natin. So, 1 times delta vertical deflection at point B. Okay? Vertical B. Okay? Delta VB is equal to the summation of FV FL over AE. Okay? So, pwede nating ilabas yung AE dito. 1 all over AE. So, i-add lahat natin yung FVF times L. Okay? So, ang pinakamagandang gawin dito is gagawa tayo ng table. Okay? So, gawa tayo ng table. Okay? Summation FVFL. Okay, so gawa tayo ng table class. So, we have ilang member yon? 1, 2, 3, 4, 5, 6. Okay? So, ito yung member natin. The next column must be the length. Okay? The next column is sabihin natin yan yung F natin. Hindi nagbabago yan, no? Yan yung due to the actual force natin. And then this FV1. Okay? FV1 uh, pertains to the virtual member force due to the vertical concentrated load. Okay? Then, pwede natin kunin yung summation or yung F times FV or FV times F times L. Okay? O FV1 pala ito. FV1. Okay? So, ito yung mga member natin. Lagay lang natin dito A, B, AD, we have BC, BD, and CD. Try ko lang to para walang sobra. Ano? Okay? So, yung L natin, lagay natin dito. Ano? Yung mga length ng bawat member. So, length ng AB is 4. Yung AD natin, that is 5 square root of 2. Or 4 square root of 2, I should say. No? 4 square root of 2. And then, yung BC natin is 3. Yung BD natin is 4. And yung ating CD is 5. Okay, yung F natin, ilagay natin. Pati yung sign, no? So, positive 21. AD is negative 79.2. BC here is positive 21. BD is 84. O, positive 84. CD is negative 35. FV1, lagay natin yung mga virtual member force due to the 1 unit load, 1 vertical unit load. So, unahin sa AB. Ang AB natin is 0.429. AD natin is negative 6 o 0.606. BC is positive 0.429. Ang BD natin is 1. And ating CD is negative 5 all over 7. So, kunin natin yung FVF times L. So, i-multiply lang natin ito. Okay? So, 4 plus times 21 times 4 o 0.429. Lagay natin. Kunin natin yung sabihin natin up to 3 decimal places. So, 36.036. Pati sign lagay natin. No? So, 4 square root of 2 times negative 79.2 times 0.606. So, negative. Huwag mo kalimutan yung sign. So, lalabas na sagot dito is 271.502. Then we have here 3 times 21 times 0.429. That is positive 27.027. The next is 4 times 84. That is 336. Then next is 5 times negative 35 times negative 5 all over 7. Lalabas 125. And then, i-add lang natin dito. Okay, so summation, FV1F times L. Ito na yun, yung kinakailangan natin. I-add mo lang yung nasa column na to. Okay, so 125 plus 336 plus 27.027 plus 271.502 plus 36.036. Nalabas na sagot is 795.565. Okay? So, 1 times delta VB is equal to 795.565 all over AE. Yung A natin is 1,200 mm square siya. So, kailangan nating i-convert sa meter square. So, i-divide lang natin ng 1,000 raised to 2. Okay? And then, E natin is 200 times 10 raised to 6. Gawin natin kilonewton per square meter. Okay? So, ano yung lalabas sa sagot natin dito? So, 795.565 divided by 1,200 divided by 1,000 square times 200 times 10 raised to 6. Okay? So, ang lalabas sa sagot dito is 3.315 times 10 raised to negative 3 meters. Or, in mm, so 3.315 mm. So, ano yung direction niya? Positive ang lumabas sa sagot, ibig sabihin, it is the same direction dun sa ating virtual load natin. Downward. Okay? So, next, how about horizontal deflection? So, paano naman yung horizontal deflection? So, maglagay ulit tayo ng panibago dito, FV2. Ang FV2 naman, due to the horizontal unit load. So, the same structure. So, gawa tayo ulit dito sa baba. Yan. Gawa tayo dito. Okay? So, meron na tayo dito. So, ang gagawin natin, ang ilulod natin dito is okay. Yan. Maglulod tayo dito ng 1. So, ibaba ko ng konti para makita na nag-load tayo dito. Nag-load tayo dito ng 1 kilonewton horizontal force. Okay? Hindi lang mismo para makita lang natin. Okay? So, sa point B yan nakaload. Baka sabihin nyo, sir, malayo naman. Okay? So, para makita lang, para ma-distinguish lang natin na nasa point B siya. Okay? Na niload. So, yun. Meron tayong vertical dito. AY. Meron tayong CY dito. Ano? And then, we have here yung ating AX. Okay? So, dito, as you can see, magiging 0 ang AY sa CY. Bakit 0? Kasi pag nag-moment tayo sa point C, okay, magna-neglect yung dalawang horizontal dito. So, AY is equal to 0 and also CY is equal to 0. Okay? And then, ang magkakaroon lang tayo ng force dito is yung AX natin na ang direction niya is going to the left. Okay? Para ma-kontra niya yung load natin na papuntang right. Okay? Sir, bakit papuntang right yung ginawa natin, hindi papuntang left? So, this is an assumption. Okay? Pwede naman papuntang left, ang gusto mo, okay lang. Okay? No problem. Okay? Ang ginawa lang natin, going to the right. Okay? Wala namang kaso yan. Kahit anong direction mo sa horizontal unit load. Ganon din sa vertical unit load. Pwedeng pataas ito, nilagay natin. Okay? So, next is member force na. Yun talagang kailangan natin. So, sa member force, sa point A, kung titignan natin, sa point A tayo mag-FBD. So, 0 to. Malamang yung ating AD is 0. Kasi wala tayong ibang load dito. No? Wala tayong vertical load dito. Ay 0 yan. So, automatic, This one is 0. So, 0 to. Okay? So, ang meron lang tayong member force dito is yung AB. That is equal to 1. Okay? Tension siya. So, positive 1. Okay? And then next is here. So, point. Itong member na to. BD. Yung BD natin, automatic 0 yan. Kasi wala namang vertical force. Siya lang. Okay? Next is itong BC. So, anong force sa BC natin? So, let's draw the FBD at joint C. So, dito yung 1 natin, yung AB natin. Andito yung ating 1 kilonewton, yung ating external virtual load. And then, andito yung ating BC. So, ano yung BC natin? Summation forces, okay, along x is equal to 0, positive. Ito, meron tayong member force dito. Meron tayong member dyan, pero automatic 0 yan. Okay? Sa joint B. So, yan, positive going to the right. So, we have BC, we have 1, positive 1, and then negative 1 is equal to 0. So, magka-cancel yung 1. So, BC is equal to 0. So, 0 ang BC natin. Automatic, this CD is also 0. So, pwede natin ilagay na dito, plus yung FV2 natin. So, AB, ang FV2 natin is 1. Ang AD natin is 0. Okay, ang BC natin, BC, saan yung BC? Ito, diba? B, tapos C, 0. Okay, and then BD is also 0. And CD is also 0. Okay? Maliwanag ba? Yes. So, next, let's get so pwede natin burahin ito, no? Para magkaroon tayo ng space. Yan. Nakuha naman na natin tong figure na yan. So, let's have the next column. So, ang next column natin is F V2 F times L. Okay, automatic yung mga FV2 0, 0 na yan. Okay? Ang matitira na lang yung AB natin. So, ang FV2 natin is 1 times F, ang F niya is 21. So, 21 times 1 times L is 4. Okay? So, ang lalabas is 84. Okay? So, ang summation, FV2F times L is equal to 0. Ay, sorry. Hindi pala 0. 84. Yeah. So, para makuha natin yung delta for horizontal deflection at point B, HB, is equal to the summation of FV2FL all over AE. Tama? So, ang FV2FL natin, okay, summation of FV2FL natin, nakuha natin yan, 84 divided by AE, the same lang naman doon. So, 1,200 all over 1,000 square times 200 times 10 raised to 6. So, ang lalabas na sagot dito, so 84 divided by 1,200 all over 1,000 square times 200 times 10 raised to 6. So, ang lalabas na sagot dito is 3.5 times 10 raised to negative 4 meter. Gawin natin mm. That is 0.35 mm. Okay? So, ang sagot natin dito is positive siya. Therefore, ang direction niya is the same do sa ating assumption na going to the right. Okay? So, ito na yung mga sagot natin. So, I hope na sundan natin. Okay? Yung pag-solve ng deflection sa thrust natin due to the loadings using virtual work method. Okay? So, the next example natin is paano naman kapag dahil sa temperature changes. Okay? So, please watch the next video regarding due to temperature changes. Thank you very much, and I hope you learned something in this tutorial.